In this video, we'll cover the powerful combination of variables and iterators. We'll see how the file, grid, and table iterators work in tandem with variables to create theoretically infinitely scalable environments. Let's begin with the file iterator, which uses RegEx to match on various aspects of file metadata, such as name and modified date. In this case, we'll match on name. We have an S3 bucket with daily flight data for major carriers. Note the 10 files prefixed with AA, representing 10 days of flights for American Airlines. Also note that today's date is January 10th, 2025. In Matillion DPC, we have a pipeline with two variables, PL flights load and PL date today. After creating a daily flights table, if it doesn't exist, we have a Python pushdown component that updates the PL date today variable with today's date. After the Python pushdown component, we're pointing to a file iterator component with some RegEx that's using the PL date today variable to look for airline codes followed by today's date and then by the string .csv. Any matches are passed to the PL flights load variable, which in turn is used in the underlying S3 load component to fetch the matching file. This repeats the number of times that the RegEx finds a match. Thus, we fetch all of today's data from the S3 bucket and load that data into the daily flights table. Once the data finishes loading, we print the PL flights load for confirmation. Running the job takes about 20 to 30 seconds and loads today's data. No matter how many files we have in the S3 bucket, or how many airlines we add to our data, if the naming convention and the RegEx line up, we'll always return today's data. Note in the results of the job run, we have rows that were loaded from 5 files representing 5 airlines, the last of which was WN, which is Southwest Airlines. Next, let's consider the grid iterator. In our Snowflake environment, we have an airlines lookup table with a list of airline codes like DL for Delta. In Matillion DPC, we have a grid iterator pipeline with two variables, PL Airlines Grid and PL Orc Airline. The PL Orc Airline variable is scalar and thus holds only one value. The default value is AA for American Airlines. Let's look a little more closely at the grid variable. Grid variables are designed to contain not a single value, but an array of values. In this case, our array of values is comprised of a single column called airline. No default values have been defined. Instead, we're using the query result to grid component to provide the airline values to the variable by accessing our lookup table airlines. This array or grid of values is then passed to the grid iterator, PL Airlines Grid, so that it can run an underlying transformation job, once for each match. Two variables are tied to the run transformation component. One of these variables we've already seen, PL Orc Airline. Let's see where the PL Trans Airline variable comes from. I'll double-click on the Run Transformation component and note that this is where the PL Trans Airline variable is defined. Its value is defined by what it receives from the parent job. The filter in the pipeline is designed to filter by the value passed to the variable. The job ends by creating a view which uses the PL Trans Airline variable to name the view. Thus, when we run the parent job, we'll create views for each airline. Once again, we have a scalable solution because as we add values to the airline's lookup table, we'll automatically add views for each of these airlines. Lastly, let's consider the table iterator. Note that I have a lookup table called cities that includes the names and locations of various cities. In an orchestration job, I'm using a table iterator component to map values to variables, one for the city name, one for the latitude, and one for the longitude. Next, I'm mapping these variables to a corresponding set of different variables in a nested job. That nested job makes a call to an API to fetch weather data for each city based on the criteria I provided. After retrieving the data, The component uses the city name to create and populate a table. Thus, when I run the parent job, a table is created for each city listed in the city's lookup table. Once again, I have a scalable solution using variables and an iterator to create any number of tables automatically. In this exploration of variables and iterators in Matillion DPC, we've seen how these powerful tools unlock scalable and dynamic data workflows. File, grid, and table iterators combined with variables provide a flexible foundation for handling diverse and expanding datasets. By leveraging these, you can design pipelines that not only meet today's requirements, but also scale as your data landscape evolves. With the right implementation, your data pipelines can be resilient, efficient, and ready for the challenges of tomorrow.